This question number 1, 2022 JEE Advanced paper. It says two spherical stars A and B have densities rhoA and rhoB respectively. A and B have the same radius and their masses are MA and MB respectively, and they are related like this: MB is equal to twice MA. Due to an interaction process, star A loses some of its mass so that its radius becomes half, while its spherical shape is retained and its density is also remains rhoA. The entire mass lost by A is deposited as a thick spherical shell on B with the density of the shell being rhoA. So this density remains the same when it is get deposited in the second star. If VA and VB are the escape velocities from A and B after the interaction process, then we need to find the ratio of VB upon VA, which should come like under root 10 n upon 15 raised to power 1 by 3. Then we need to find out what this n is. So I have solved over here, and let's see how it's going. So first of all, we need to think about this escape velocity. So escape velocity is the minimum velocity that is required for a body to escape from that star's gravitational force or field. So we'll say the kinetic energy is like half mve square, and the potential energy is going to like m into v with a minus sign. V is going to be written as a positive now. So this total energy later on becomes 0, where v indicates gravitational potential as magnitude of it. So from here, escape velocity turn out to be under root 2 times v, gravitational potential. And then the ratio of escape velocities B and A will be under root VB divided by VA, where VB, VA, these are the gravitational potentials. So this question boils down to finding out the potential outside B sphere and outside A sphere after the interaction process is completed. Moreover, there is further information like this. It says masses are like this relation, they are connected together. So we can convert these masses into density into volume. So, and the radius are identical, then you'll find this density of B will be equal to twice of density of A. So wherever required will be coming, we will be using this. Now gravitational potential just outside these stars after interaction process can be calculated as follows. Potential outside the sphere 1. Now outside this spherical body, if it is uniform mass distribution, is given by minus gm upon r. Now new radius of the sphere 1 or A becomes r by 2, and let's say mass is this ma prime. Now you know this mass will be since its radius became half. So as per this equation, mass is equal to density into volume. Half radius will indicate for the same density as m by 8 mass. So this is going to be the new mass, this is the new radius. So that will turn out to like minus 1 by 4 gma upon r. So this is the potential just outside the sphere 1 after the interaction process. Now the challenging part was to find out the gravitational potential outside of star B. Now this is star B, this is of r radius initially, this was of r radius initially of density rhoB, and then over that this rhoA density has been deposited. Let's consider the final radius became rb prime. So we need to find this rb prime first. Now for that this calculation has been done. So mass added, how much mass added on B is going to be, so this has to be B. This mass is going to be added on B, and that mass is coming from A. So you will find MA was the original mass, MA by 8 remained, so deposited mass is going to be like 7 MA by 8. Now this 7 MA by 8 will be is equal to the density into the volume. Density is going to be rhoA, volume of this annular part, so that will be 4 by 3 pi rb dash cube minus r cube. Since mass of B can be written as rhoB 4 by 3 to pi r cube, this is original mass of B. Now using these two, we can find out relation between rb prime and r. Now since we know this mb is twice ma, so I can write it as a twice ma, and we can divide these two. Once we divide these two, then it will become 7 divided by 8 into 2, that is 16, is equal to rhoA upon rhoB, and these terms will get cancelled out, and there will be like r dash b cube minus r cube divided by r cube. Then we know the density of B is twice of density of A, so density of B can be written as twice of density A, so this will be 1 by 2, then it will be like 7 by 8 again. 7 by 8 R cube is equal to R dash B cube minus R cube. After simplification, this RB dash cube came out to 15 by 8 R cube. Taking cube root both sides, RB dash came out to be like 15 raised to power 1 by 3 R by 2. So this is the new radius of star B. Now, to find the potential or just outside the star B, first we need to find a field outside at any point, because potential is the work done by external agency to bring a positive mass or mass, unit mass from infinity to outside. So we require the field outside the sphere. So using this Gauss law, E dot ds minus 4 pi m g and mass enclosed, and that will say minus E into 4 pi r square using the Gaussian surface, which is spherical outside of a smaller radius, and the total mass enclosed will be like mb plus 7 ma by 8, so mb 7 ma by 8. Now from here we can find out this E expression. We know this mb is twice ma, so that will turn out like 2 plus 7 by 8. 16 plus 2, that is 7, that is 23 by 8 ma. So this becomes the formula for gravitational field outside this star B due to star B. And since this is a gravitational field, then potential will be like E dot dr, and integrating from infinity to that point, so it turned out like minus this number and 1 by r. Now since we are looking just outside, so this small r can be replaced by r b dash, so minus 23 by 8 gma. Now since it was in term of ma, so it's ma rb dash. Now this is potential just outside of star B. This was the potential just outside the star A. Now since we know this VB upon VA is equal to ratio of this, so we need to work on the ratio, then square root, so there is a square root and the ratio. When we divide this VB with this, then you find GMA upon GMA will get cancelled out, and it will be like this has to be upside, right? So this will be 23 divided by 8 RB prime, and that downside will be GMA, which is cancelled out. This 4R will go upside. And then you can simplify this, so this RB dash can be written from here, so that's like 2 after cancelling them out, so 23R divided by 2, and RB prime is 15 raised to power 1 by 3 R by 2. Now this 2 and this 2 settle down, and R is R settled down, so this turned out to be square root of 23 divided by 15 raised to power 1 by 3. Now the question says this has to be in this format, so this 23 can be written as 10 into 2.3. So this n which question demands for must be 2.3 as a numerical value, and the decimal numbers are allowed, so 2.3 will be the response for the first question. Okay, so this is how we need to solve this question. Thank you.